So it's circles day 2. So basically we're going to go over the same stuff as yesterday, on Friday. Parent equation for the circle, how to change that, move it. You know, you're not going to be stretching circles, although it is kind of cool to make ellipses, but we're not going to do that. And then domain and range of circles. So anyway, here is a picture. I'm going to give it a second just to refresh. I'm going to pause. Okay. All right, there, it's working. So here are some equations, and you got to kind of get over that this has, you know, this is a little squared, and that's a squared. All right, so given that, which of these on the right-hand side would go with it? And then if you have this on the notes on the iPad, I'm not sure if this part's showing up or not. You might have to look at the board. Well, this is a circle that's been moved. Do you remember what this means again? Right 3. Careful on this one. Up 4. Yeah, it seems like it should be down 4. But remember, circles are counterintuitive now too. So if it's been moved from the center, which is normally at 0, 0, to right 3 and down 4, up 4, I almost made the mistake again. Do you see that the one on the right is this one? So I should be able to put this in here. And my software little thingy bob that's supposed to work here is not allowing me to drag those. I'm going to try it one more time with a mouse and see if it'll let me. Come on, be nice. Nope, it's not going to let me, so I'm not going to try to play that game anymore. This one probably won't work either, so I'm going to skip on to just plain old pictures of graphs. Sorry about that, those used to work, but something's wrong with Flash. All right, so graph the following. This is a circle. Do you get that it's been moved? Which way did it get moved, right or left? Left, and then which way did it get moved, up or down? Be careful. Up, all right, and then its radius isn't 25, that's for sure. What is its radius? 5, all right, good. Would you please make a sketch of this? I know you may not have graph paper, but make a sketch of what that should look like. You'll need paper. Don't just sit there and watch me. Nope. Paper. Virtual paper is, of course, fine. A lot of yours don't work, so paper works fine. Just a quick sketch. So you got a little circle. It's got a radius of 5. It's actually a fairly biggish circle then. I would always start with the center. And let's see if it's left 1 and then up 1. Center's right there. You see why I'm going to make a little mark here? And there. And there. And there. So that I can make my circle go through those. Okay? You get that? If you get this, then you basically have circles. You just, domain and range from here is more about, do you understand domain and range? Domain's this way to this way, so what's the furthest it can go to the left? -6 to how far on the right? And then do I have parentheses or brackets? Brackets, because it can touch those spots. So they need to be brackets. If it's something like you get really close to but never touch, you have parentheses. All right, and the range from the low of -4 to the high of 6, and also brackets. Any questions on those? All right, I feel like circles is really easy for you. I want to just do one where I don't actually give you any help. Make sure you're totally solid with this one. Make me a sketch, what this guy would look like. I'm going to come around quick and check them. So please have this ready to be checked. And I want to go really fast, so when I walk near you, hold it out to me. Okay. So for my quick check, there was only a couple people that had little mistakes, and I think you're all understanding this pretty well. This was a 4 to the left, and then the circle went like that. That's not a beautiful circle. It has to go up 4, so it really needs to go up like more like that. Okay, so it goes from -8 to -1, and then the range is from -4 to +4. And all brackets on everything. Okay, good enough. Let's stop talking about drawing the, or writing the circle. Let's talk about writing the equation. So I'd like you to try to write the equation for this little circle. Given this circle, what would the equation be? Unlike most equations, we don't start with y equals. The most common complaint I'd have is that people forget the squareds, x and a y, and then has it been moved left or right for the x? It's been moved right 3, -3. And then has it been moved up or down? And this is the one people goof up a lot. It's been moved down, but I don't put -1, I put +1. Raise your hand if you had that part right so far. Good. Then the last part you'll probably all get right. And it's just a radius of 2, so you could either put a 4 or you could put a 2 squared. Either way works. All right. Then the domain and range for it, that's getting pretty easy and repetitive, so I don't think we need to do that. We had enough practice on those. All right, this last kind of the most brutal kind, where you have to try to solve for y, and a lot of you are not very good at that. I'm going to show you the one on the left here, and then I'm going to have you try the one on the right. If I'm solving this for y, the first thing I do is get rid of that. So I'm going to subtract x plus 4 squared from both sides. So then I have y minus 3 squared equals 16 minus x plus 4 squared. Okay, so I'm getting closer to getting my y alone. Next thing I got to do is get the squared off of there. So I square root both sides, and this is trickier than people think, because this is absolute value of y minus 3. And the other side, you can just leave messy. 16 minus parentheses x plus 4 squared. You don't need to multiply that all out. It's fine. Next thing, I'm going to split this into two equations. Y minus 3 is the square root of 16 minus parentheses x plus 4 squared. And the other side, y minus 3 equals negative. The only difference right there. Square root of 16 minus parentheses x plus 4 squared. And there's my two answers, right? No, y isn't alone yet. One more step. Add 3 to both sides. There we go. And on this one, I'm going to add 3 here and add 3 there. Okay, there's my two massive equations. All right, I'd like you all to try to solve that one for y without my help. This is pre-calc level stuff. You needed that? All right. It's not going to be exactly the same. Yep. Does give you help, I guess. Did you already solve it? Already done? Are you already done? I just can't tell if that is that the one up there. Oh, wow. You're fast. Some people just started. If you were having a hard time starting, you subtract x squared from both sides. Then you'll need a square root. Okay, so I know that was tough. I want somebody to talk me through it. First do this, then do that, then do this, then do that. It's B. Tell me what to do. Okay, good. Subtracting x squared from both sides, I get y minus 1 squared equals 25 minus x squared. Keep going. Square root, square root. Y minus 1. 25 minus x squared square root. Okay. Got it. splits. Hold on. Not your fault. There we go. Okay, y minus 1 equals square root 25 minus x squared, and y minus 1 equals negative square root of 25 minus x squared. Okay, now what? Close. All right. Plus 1, plus 1, plus 1, plus 1. And then these cancel, and I have y alone. There it is. There's the one of them. And the other one is that one. And the only difference is one's got a negative in front of it. All right. Any questions? Okay, I know those were our challenging algebra ones, but we need to stretch you a little bit. It is an honors class. The Circles Day 2 worksheet is what we're doing for today's homework, but I'm actually going to assign you a little less of it than the full thing. I'm going to hand them out because, again, I know a lot of you have issues with your iPads right now, so I'm going to hand out your circle worksheet here, and we're going to skip a bunch, and then we're going to start the review, which is officially supposed to happen tomorrow, but there's a lot to review in one day, so I'd rather do some of it today. All right, so I'm going to pause for a second while I hand these out, and then we'll do some review. Okay, so I just handed you 2 worksheets. The one on circles, we're going to skip several. We're going to just do on the circle part A, C, and E, ACE. We're going to skip B and D on all parts. Okay, so go through and cross off B and D. You don't have to, like, you know, make them impossible to read in case you want to do them. But B and D are going to be skipped. A, C, and E are going to be done. Then on the front part, there's number 2. On problem 2, same deal. Cross off B and D. Cross off B and D. So B and D on the front page are all gone. Okay, now turn to the next page on circles. And I'd like you to take out B and D again. We're on problem 3, cross off B and D. Then I think we can keep with the same. Okay, skip number 4 completely. Skip number 5, B as in boy. And on the back page, that review, that's kind of really important because it's the review for the test. So I think you should do all of those. Okay, now on the other packet is actually tomorrow's homework. I've just given it to you early. I am going to assign all on that, so you can do it whenever you want. If you want to do some of it today, you can. You don't have to. Okay. So I'm going to do a little bit off of that review packet, though, for you right now. So everybody start with the Chapter 4 review packet up in front of you. Oh, you know what? There's a bunch of review at the beginning that's just like what we did. Okay, I got one more thing to skip then. On the circles packet, go to the back page. It is review, but we have more of it on tomorrow, so we don't need that much review. Why don't you cross off the bottom one? There's 2 sets, you know. Cross off the bottom set of problems. Okay, so we have decimated. Although technically it's not decimating. You know what decimate means? A tenth of something. Very good. So if you decimate the opposition, it means that you have cut them down 9/10 of their size down to only 1/10 of what they used to be. Okay, anyway. So in the review, I am recording, and that's okay. I'm about to do a few problems off the review packet. So I am now moving to problem 2 in the Chapter 4 review. It's got a little box that looks kind of like this. Okay, that little guy. And we're supposed to do some stuff to it. Let's do the first one. Y equals 0.5 f of x. That's the first question under problem number 2 on the Chapter 4 review. Okay. So that's half of, well, half of what? It's on the outside. Is that the up, down, or the left, right? Up, down. It affects the up, down. So it's half as what? Half as tall. Okay, so all you have to do is make the thing half as tall. Same width though. Still got to go from here to here. But now everything's half as tall. So I'm going to just take this point and make it half as tall. This point, make it half as tall. And there's my new graph. Boy, that's ugly. Let me try again. Something to do with my calligraphy pen is making this challenging. Anyway, okay. I'm going to draw your attention to letter E as an elephant, because on problem 4E, everybody flip your packet to the next page, look at that, because this is a graph of time versus distance, but it might confuse you a little bit. It's distance from his blankie. Okay, so this is time. First of all, label it. This is time. This is distance from blankie. Let's make sure you understand the difference. If I just did a time distance graph, no matter what direction I was walking, I would be increasing my distance. Get what I'm saying? But if I'm doing a distance from blankie, if I'm walking away from blankie, that would look something like this. If I stop, that would look something like this. If I'm walking back towards the blankie, if I was doing a total distance graph, I'd still go like this, but I'm not doing a total distance graph. I'm doing a distance from blankie. So if I'm walking back towards blankie, eventually, what would that mean? I got back to blankie. All right. Now, I'm not even going to ask, because I'm sure you wouldn't admit it anyways, but I'm sure many of you had a blankie or a teddy bear that was special to you. So this is just measuring that type of a graph. This is not the answer. You have to figure out based on the picture. But I wanted to remind you, if you get all the way back to blankie, that is not a distance like way up here. Yeah, the kid walked a long ways, but that's not what we're going for here. On the distance from blankie, they'd be back to 0. All right. Okay, that's all I got for you for today.